All right, so the first example I have is the sine of y is equal to 3x squared minus 2. And again, we want to find the first derivative, dy dx. So I go through, I take dx of both sides. Now, again, because the variable of our trig function is y, I need to put in there that this is the derivative of y with respect to x. Now, the next piece is, what is the derivative of the sine of y? Well, the derivative of the sine of y is just the cosine of y. Now, on the other side, what do I have? This the derivative of 3x squared minus 2, and that is just 6x, and that's the use of the power rule. Again, the derivative of 2 is just 0, so you don't need to write that down. And then the last step with this is to go ahead and divide both sides by the cosine of y to get the fact that you have dy dx is equal to 6x cosine of y. Now, we're going to go ahead and look at more complicated examples. The next example is going to have the product rule and then the chain rule. All right, so when you're looking at this, hopefully you notice that this is the cosine of x times the sine of y, and that indicates that we have to use the product rule here. I'm going to use this and do this two different ways. If we want to talk about the UV notation with this, if u is equal to 4 cosine of x, the derivative of u is just going to be 4 times minus the sine of x, or minus 4 sine of x. And again, we are looking for the derivative with respect to x. That's why that stays the same. Now, looking at v, if v is equal to the sine of y, then the derivative of v, I need to add in that this is dy dx. The derivative of the sine is the cosine of y. Now, I could also have left the 4 on the outside to all of this. I just happened to choose to put it here. All right, so what are we left with? We are left with minus 4 sine of x times the sine of y. That leaves us with minus 4 sine of x times the sine of y. I add that to 4 cosine of x times dy cosine of y. That leaves us with dy dx 4 cosine of x cosine of y is equal to 0. And again, the reason that's equal to 0, the derivative of a constant is just 0. If this was anything other than a constant, you would have to take the derivative of the right-hand side as well. Now, the same goal is to find dy dx. So we're going to go ahead and take this and move it over to the other side of the equation by subtracting both sides. And this leaves us with dy dx of 4 cosine x cosine y is equal to 4 sine x sine y. I want to continue and divide both sides by 4 cosine x cosine y. The 4 over 4 becomes 1, and dy dx is equal to, this no longer needs to be written as sine over cosine. This is the same thing as saying the tangent of x and the tangent of y. So we're going to start this one the same way. We are going to take d dx of all of the terms. Now, when I go through and do this d dx of the sine of x, that is as straightforward as it comes. That is just the cosine of x. Now, the next one coming up, this, we actually need to remember that we're going to have to use a chain rule with this. So, d dx of 2 cosine of 2y. That tells me that I need to write this as dy over dx. And again, that's because this is y, and I want this derivative of y with respect to x. I need to write that down. The 2 comes along. Now, I take the derivative of the cosine of 2y. The derivative of the cosine of 2y is just minus the sine of 2y. But remember, this is a case where we have to use the chain rule. And now I take that inside, the derivative of that inside is 2. All of this is equal to d dx of 1, which is equal to 0. All right, so let's simplify this a little bit. That leaves us with the cosine of x plus dy dx of, I'm going to combine this 2 and this 2 and make that negative 4 sine of 2y is equal to 0. Now the goal is to get dy dx all by itself, so the cosine of x moves to the other side. And now I have dy dx of minus 4 sine of 2y is equal to minus the cosine of x. I now go ahead and divide both sides by minus 4 sine of 2y. And my final answer is going to be dy dx is equal to positive cosine of x all over 4 sine of 2y.